are familiar by now with the concept of a function, a point, and a derivative, right? So the slope of this line equals f prime at a. So let's say this is a. And you've already determined so many different equations, right? Equation of the tangent line. And I'm sure you are tired of this. Probably 2 or 3 problems in each section. We're giving us a function, they were giving us a point, or maybe just x, asking us find the equation of the tangent line. Find the equation of the tangent line. Why? Why is this so important? Okay, and you will see now why it's so important. But I will not start with linear approximations. I like to start with differentials. And this is a concept that is key to understand. Okay, so let's take a look at a function. Here is function f of x. Of course, here's the point. And this point is point A or P, doesn't matter. And I am going to say that Q, as you know, we already talked about this, the difference quotient. We know that Q is very close to P. Okay, so we know that the coordinates here are x and of course f of x. Q is very, very close. So we know that you're going to say, why don't you put here little h, as we did before? No, we have a different notation now, dx or delta x. And you can say, what's with this delta? You taught us that this is delta. What is this delta? This is lowercase delta, this is uppercase delta. Still delta. So of course this is either x plus dx or x plus delta x. So these are both delta. And of course, you're going to tell me what this is. What is this height here? Anyone?
F of x plus delta x.
Thank you very much. So f of x, I'm going to write dx, equals, as you mentioned, f of x plus delta x. They are both the same. So this is right here. Okay, so now, of course, you know what I'm going to do next. I'm going to draw a tangent line at P, but I'm going to extend this line. And I'm also going to extend this line, the vertical line, through Q. I'm going to extend this line as well through P. And first I'm going to ask this question. What is this? So, before I get back, let's assume I have a disk. And this disk is supposed to have a radius, let's say for simplicity of 1 inch. But when I measure this radius, I get 0.9. Or I may get 1.1. I do not get exactly 1 inch as is supposed to. Well, this means that there is a delta x or dx because x is my independent variable. Either delta x or dx, or if you want to call it dr for radius, that's fine too. So there is an error here. In my example, the error is plus or minus 0.1 of an inch. This is this error. So I said Q is very close. I had to zoom in so I can explain what I'm doing. But Q is very close, which means my error, tiny error, dx or delta x, or if you want to talk in terms of dr, same thing, it's a minor error. But the problem is that this error will create an error in the area. So dr, or if you want dx, or if you want delta x, or if you want delta r, doesn't matter, triggers an error in the function. In my example, the function is the area. So if the radius is exactly 1 inch as it should be, then the area will be pi r squared. But I do have an error, a minor error in the radius. Well, there must be an error in the area then, because there is an error in the radius that triggers the error in the area. So coming back here, if I have an error in x, what will this represent? So this is f of x, and this is f of x plus delta x. What will this represent? Based on my example, what would you think it would be?
Would it be like the size of the error?
Exactly, in the function. Exactly. This is denoted by, not surprisingly, delta y. So delta y is the exact error in f of x triggered by delta x or dx due to delta x. Awesome. Now, can anyone give us the formula for delta y, for the exact error from the graph? What will be delta y equal to?
F of x plus dx minus f of x.
Brilliant. Indeed. So it's f of x plus delta x minus f of x. Same thing with f of x plus dx minus f of x. Done. Okay, so you can say, what's the big deal? You didn't teach us anything. It's obvious. That's not even calculus. You have point P, you have point Q. For this change in x, you get this change in y. Brilliant, but what's the point? Okay, stay with me, please. Okay, now you see I have a triangle here. This triangle. I'm going to remove it from here because I don't want to put too much stuff in there already. I have enough. Okay, so here is that triangle. Here's the function f of x. This piece is dx. This piece is dx. I already know the slope of this line. Can anyone give us the slope of the tangent at P? From what we studied so far in this course, what is the slope of the tangent line at P? equal to.
F prime?
Thank you very much, of x. Excellent. Thank you. Who said that?
I did.
Thank you. Good. So I have the slope of this line, and I also know that the slope of the tangent line at P equals rise over run. I know the run. I don't know the rise, but I know that this equals to f prime of x. Can anyone guess the run? We've seen this probably 30 times by now.
Is it dy?
Of course. Of
What's
course,
dy?
it has to be dy. I never told you till today that these two pieces, all the time I said to you, this is a unit that represents this. This is a whole that represents this. I never really told you till today that this has a meaning and this has a meaning. So I need to come back to my drawing because this is dy. Remember, I have to explain in writing what dy really represents. But for now, remember Q is extremely close to P. I would like you to give me a relationship between delta y and dy before I even explain what this is and what this is in a minute. Let's look at the graph again and look at Q being very, very close to P. I would like you to give me a relationship between delta y and dy, keeping in mind that Q is here. And no, you cannot say equal.
So the limits?
So I'm waiting for a symbol here. And you cannot say equal.
Less than.
We don't know that.
Not equal?
That's good.
Would it be as changing y approaches q, it approaches dy?
Close. One last chance. They are approximately equal, but not equal. This is exact. This is not exact. I'm missing a letter here. It's not exact. And I will determine it in a minute. Okay, so let's identify what dx is represent. So delta x and dx are the error in x. This is called differential of x. Good. Delta y, we know exact error in the function. dy. dy is, of course, the differential of y. or f of x or y. Can anyone solve this equation for dy for us? So we can write the formula for dy.
dy equals dx times the function.
Excellent, f prime of x dx. So I'll come back to this because this is extremely important. That's what we are talking about. But before that, I want to make sure that this is clear moving forward. Derivative versus differential. Of f of x. Please understand they are completely different. The derivative of f of x is f prime of x. The differential of f of x is dy equals f prime of x dx. So do not confuse the two. If we're asked to find the derivative, this is what we determine. If we're asked to find the differential of a function, we have to write this. And of course, we have to differentiate the function times dx. Okay, so we discovered this relationship. So then, delta y approximately dy. This one we already know is f of x plus dx minus f of x. You gave it to me when we talked about it. The approximate symbol, we already know what this is. So this is f prime of x dx. Yes, I'm going to move this to the other side. So I have f of x plus dx is approximately f of x plus f prime of x dx. Super important. And it will follow with an application right